Hello, my name is Muhammad Azan bin Abdul Karim and this is Aini Shabaha binti Muhammad Nasir. Today, we are going to present about Lab Experiment 2, Momentum and Energy. So, the objective or purpose of this experiment is to determine the velocity of a horizontally projected object, a metal ball, fired from a spring gun using conservation of linear momentum and conservation of energy considerations. For energy theory, the energy is always conserved. There are different forms of energy, and one form of energy may transform into another form of energy. Mechanical energy is a form of energy that is not always conserved. Kinetic energy, K, and gravitational potential energy are the mechanical energies being investigated today as K equal 1/2 mv square, and where a mass, m, has energy due to its speed, v, is Pe equal to mgh, where a mass, m, has energy as a result of its position, height, h, and g as acceleration due to gravity.
For the momentum is a vector quantity since it comes from velocity multiplied by mass. There are three different categories of collisions: elastic, inelastic and perfectly inelastic. In this experiment, perfectly inelastic collisions are used to determine the initial velocity of the ball. Perfectly inelastic collisions refer to collisions that result in objects becoming attached to one another after they collide. The objects hence move together with the same velocity. These perfectly inelastic collisions conserve linear momentum but not mechanical energy. Conservation of linear momentum between state 1 and state 2, before and after collision. For the apparatus, we use ballistic pendulum apparatus in the lab, which consists of spring gun designed to project a metal ball in a horizontal direction with a hollow pendulum able to catch the ball in a completely inelastic collision. For the procedure, the mass of the metal ball, m, and pendulum, m, are measured. The mass of both is recorded. Then, we prepared the ballistic pendulum and the indicator was adjusted to 0 degree. Next, the pendulum is lifted up and the metal ball is pushed into the slot by using a plunger. The next step is, the metal ball is pressed against the spring. Then, the trigger is pulled and the metal ball is shot out. Lastly, record the step 1 to 4 for 8 times and the velocity was calculated and record the data in table.